This is our stoichiometry experiment, making aspirin. We're going to be reacting acetic anhydride and salicylic acid to make our aspirin. They react in a 1-to-1 mole ratio, but we're not going to put together the exact 1 mole to 1 mole. We're going to have a limiting and an excess reagent. The limiting reagent is the one that all reacts, and it limits how much product you can get. The excess reagent does not all react, so there'll be some left over. And it would predict too much product because it's not really going to all react. It can't. There's not enough of the limiting reagent. Okay, the theoretical yield is calculated using stoichiometry, which means you're going to have to, somewhere in the calculation, you're going to use the coefficients. And in this one, the coefficients are all 1, so it makes that a simpler calculation. Okay, so theoretical yield is a calculated amount. It's the maximum possible you can make. It's based on all of the limiting reagent being used up. The actual yield, it's the amount of product observed in the lab. And by observed in the lab, in your case, you're going to get your aspirin at the end and this white powder, and you're going to weigh it on the balance, and that will be your actual yield. And then to get your percent yield, you're just going to divide times 100. Remember, the theoretical is the maximum possible. The actual is how much you got. So this is kind of a way of seeing how good your procedure was, or your technique was. Okay, and then we're also going to use a catalyst in this reaction. We do a couple of things actually to make the reaction go faster. One is we warm it up, but not too hot. Warming a reaction makes it go faster, helps it get started. We are also using a catalyst which speeds up the reaction, and that way we can get this reaction done in 15 minutes rather than waiting much longer. This is phosphoric acid, and it acts as our catalyst.